Hello there, my name's Dave Wheeler. I'm an engineer and a trustee of the Hucknall Flight Test Museum, but much more than that, I'm a lifelong aviation enthusiast. Welcome to our second YouTube video relating to the Rolls-Royce Flying Bedstead and the modelling competition being run by the Hucknall Flight Test Museum and the Rolls-Royce Hucknall Model Aircraft Club. If you haven't seen the first video, I suggest heading over and taking a look. So don't forget to hit the like button and the subscribe button below to get new information as we release it, but continue watching now for more information and details of the Flying Bedstead. The 1950s was an exciting time for potential new horizons in aviation, and as the increasing length of runways for the more powerful new turbojet aircraft became a concern, all manner of concepts were being considered. Ideas for vertical and short takeoff aircraft were now coming under consideration after Rolls-Royce design genius Dr. Alan Griffiths had put forward a conceptual design for a jet-powered vertical takeoff machine. But in addition to achieving a stable vertical takeoff and landing, any future practical machine would also need to be able to transition from a stationary hover into forward flight and back again. So from Dr. Griffiths' proposed concept, Rolls-Royce Hucknall design engineer Stan Hart produced a functional design which became the Thrust Measuring Rig, or TMR for short, and was later famously dubbed the Flying Bedstead. Now, the TMR project initially specified that the machine would be restricted to low-level flights conducted below a large safety gantry equipped with a system of motorised stabilising tethers connected to the airframe. This safety system automatically monitored and restrained any excursional movement of the aircraft to port and starboard and ensured a safe maximum rate of vertical descent. The objective of this was to allow the pilot to release the controls at any time that he got into difficulty, and the tethered system would return the aircraft gently to the ground. The TMR was fitted with a pufferjet flight control system that had been designed by the Royal Aircraft Establishment at Farnborough and was so called as it took cold bleed air from the engine compressor outputs via non-return valves to feed a modulated air pressure system, which the flight controls directed through swivelling outrigger pipes to control pitch, roll and yaw, whilst application of the throttles controlled the machine's altitude. Now, there was also a gyro-referenced auto-stabilising system fitted for the pitch and roll axes, which worked in tandem with the electrically derived control column inputs, whilst the yaw controls were purely and simply mechanical. Two Neen turbojet engines, amongst the most powerful jet engines in the world at almost 5,000 pounds of thrust each, were chosen to power the TMR, but this still only gave the machine an initial maximum thrust to weight ratio of 1.07 to 1, which improved slightly to approximately 1.25 to 1 as the fuel load burnt off towards the end of the flight. There was also an inherent lag in the throttle response, which was characteristic of all gas turbines in the period, and pilots had to anticipate this lag to maintain control. All these factors meant that the machine proved incredibly challenging to fly. So it was this arrangement that Rolls-Royce Chief Test Pilot Harvey Hayworth climbed aboard to undertake the very first successful tethered flight of the TMR 9th of July 1953, having failed to get off the ground with the previous attempt just 3 days earlier. This was due to an undercarriage problem. Wing Commander Hayworth had served with distinction in the Battle of Britain, before being seconded to Rolls-Royce as a test pilot in 1941. eventually taking over the role of Chief Test Pilot from Captain Ronnie Shepherd when Shepherd retired from flying duties in 1951. Shepherd, however, now took the decision to come out of retirement to contribute his skills to the TMR programme, bringing a wealth of valuable test flying experience to the gantry-based tethered flight trials, alongside Harvey and his brother Jim Hayworth, who had now joined the programme. Squadron Leader Jim Hayworth was another highly distinguished flyer who had served in the RAF during World War II on operations, flying both Wellingtons and Lancasters before being posted to Hucknall in 1944 to support the Hucknall Test Pilot Cadre. He was then formally employed by Rolls-Royce in May 1946. Captain Ronnie Shepherd, however, was the company's most experienced test pilot. Just prior to the TMR programme, he had come to the end of a highly distinguished flying career, which had started with the Royal Flying Corps during World War I and had progressed all the way through World War II, during which he served many years as the Rolls-Royce Chief Test Pilot, logging hours on many different types of flying testbed aircraft, all at the cutting edge of aero engine development. Initial tethered flights of the TMR revealed the controls to be sluggish, particularly in roll, with a number of system improvements necessary before they were deemed sufficiently responsive to pilot input. An extensive programme of test flights then continued under the gantry to evaluate the control modifications and further understand the machine's handling. As confidence grew with experience, Shepherd decided that he wanted to fly the machine untethered to be able to fully assess the machine's transitional flight capabilities. He therefore approached Ernest Hives, the head of flight test operations, to persuade him to agree to a free flight plan. Hives had initial concern that this proposal fell well outside the programme's original safe operating parameters. Undeterred, however, Shepherd pressed his case and eventually Hives agreed. Plans were put in place to set up a free flight test area at the southern end of the Hucknall aircraft hard standing, right next to the runway, and crucially well away from any buildings. The test area was cordoned off with steel houses set on steel posts about 6 foot high, and height gauging poles were erected around the perimeter. The idea of this was to contain the machine within the designated test area should it uncontrollably topple over and be thrust along the ground. A special firebrick pad was also built to absorb the heat effects of the high pressure hot jet efflux, which was directed towards the ground on takeoff and landing. It was vitally important that no ground debris was blown up by the jet efflux, which could potentially be ingested back into the engine intakes. So, on the 3rd of August 1954, in front of various ministry dignitaries and senior company executives, including Hives himself, the machine was wheeled down to the test area for the world's first piloted vertical takeoff flight, and Captain Ronnie Shepherd climbed aboard.
With increasing experience and confidence, the freedom permitted was extended to the point where it was deemed safe to remove all check wires, so making it possible for Captain Ronald Shepherd and other Rolls-Royce test pilots to maneuver the machine in free flight. The Flying Bedstead is powered by two Rolls-Royce mean engines, set horizontally in opposition, one on either end of the framework. The jets from these engines are ducted through 90 degrees so that both engines discharge vertically upwards under the centre of gravity. This is a favourable arrangement for balancing the device and eliminates gyroscopic effects. No attempt was made to develop special engines, for engine development is a lengthy business. Therefore, the choice was limited to available engines. and by the need to have sufficient reserve thrust to carry a pilot and adequate fuel for a reasonable running time. The machine itself is completely independent of aerofoils, control surfaces, and the need for forward speed. The pilot sits on a platform above the two engines. The control moments which he needs to balance the machine are supplied by compressed air jets, which are discharged through nozzles at the end of crossbars. The air from these nozzles is bled from both engines, and the pilot, using a conventional control column and rudder bar, regulates the airflow through the nozzles. In this way he provides the required pitching, rolling and yawing motion.
Soon after his outstanding free flight success, Shepard's health was by now seriously ailing, and he finally retired from the programme, dying a year or so later. Now, during the initial gantry phase, another of other test pilots had been invited to test fly the machine, but as the programme moved on into an expanded free flight phase, it was Jim Hayworth who now took on the bulk of the test flying programme, following Shepard's example by flying the machine outside the gantry in free flight, and this was on at least 15 occasions. In later colour footage, Jim Hayworth can be seen piloting the TMR in free flight. Here we can see just how hard Jim is working the throttles, anticipating the power response lag in order to maintain a steady hover. Pilots eventually reported that the throttle lag was the most challenging control aspect to familiarise themselves with, and once height control had been accurately mastered, the TMR became relatively easy to fly.
To give us his impressions of flying the machine, here is Mr. A.J. Hayworth, Chief Test Pilot of Rolls-Royce Flying.
It's really a very easy machine to fly once you acquire the knack. It's rather like learning to ride a bicycle. Handling is quite positive. Control are exactly the same as those of a conventional aircraft. Even in a 15-knot wind, she's quite manageable and stable. And there's no need to worry unduly if one engine should cut out. You see, the other provides sufficient thrust to get the machine down safely. Of course, later machines will no doubt have a battery of engines, which will reduce its hazard almost to nil. Of course, a great deal of investigation and development remains to be done. For example, the problems of heat, noise, safety, and the design of the most efficient engines and an airframe to employ this principle will all have to be tackled and solved.
Two TMRs were built at Hucknall. TMR-1 was designated XJ314 and TMR-2 was XK426. On January the 12th, 1955, towards the end of the Hucknall flight test programme, XJ314 was transferred first to RAE Farnborough and then to RAE Bedford, where further testing was undertaken. It crashed on the 16th of September 1957 due to a control system failure, but the pilot was uninjured. XK426 was retained at Hucknall but was destroyed in the crash, being flown under the gantry on the 29th of November 1957, killing the RAF pilot, Wing Commander Henry Larson, who had come to visit Hucknall to undertake an evaluation flight prior to the machine's scheduled transfer to Farnborough. The puffer jet control system concepts pioneered in the TMR programme were taken forward and used to develop the Hawker Harrier, and a version based upon similar protocols is still used today on the very latest F-35 Lightning aircraft. Don't forget to hit the like and subscribe buttons to get new information and details, and please leave a comment. So have a go and enter the modelling competition. The details are on the screen now, and thanks for watching.